Okay, so this gravity force is 300 Newton going downwards. The person is carrying the stick with the kid sitting on top. Well, we have to have the forces balanced. So there have to be vertical forces going upward to cancel this force going downwards, right? So where does the vertical force is going to be? So the vertical force, one is going to be here. So I'll call it F1. And then one is going to be here. I'm going to call it F2. Okay, so from what we've learned yesterday about the relationship, force going upwards need to equal to the force going downwards, and that would need to equal to 300 Newton. So that we're matching the criteria of linear equilibrium, right? Okay, and imagine you are in this situation. So how is this force going to be shared by these two? If this is absolutely symmetrical, because I give you 2 meter over here, then this two force probably will be equal size, right? Yeah, okay, I'm ignoring the force of the stick. Okay, let's say the stick is very light. Okay, so F1 is probably going to equal to F2. So now each one is going to be 150 Newton going upwards carrying it. Does that make sense? Okay, so but let's say we have a situation 2. So situation 2, I still have exactly the same thing. Still the person is going to carry a stick. And then there's another person on this side. And the stick is still 4 meters. But in this time, this kid is going to sit somewhere over here. He's not going to sit in the middle anymore. He's going to sit a little bit closer to this side. Okay, let's have a look at the force. The force is still going to be gravity going downward. And I'll tell you, now this distance on this side is going to be 1 meter. And then the distance on this side is going to become 3 meters now. And then we still have the supporting force, F1 and F2. Let's have a think which force will probably be a bit bigger. So if I call this force over here supporting F1, and this is F2, which force do you think will need to be a bit bigger? F1, right? Yeah. So we all experience this. That's way too big. Okay, just say this is F1, and then probably be a bit bigger than the F2. We all have this experience. That's because when we're carrying something, so if you ever carry something with your friend, right? Whoever is stronger probably carry the heavier side. Because if the heavier side is too close to you, you will need to use more force. Does it make sense? Okay. So I've actually did this experiment 1 year. So I just had a big bamboo stick over here. I asked a student to hold a bamboo stick with me and asked the other student sitting in the middle. And then I asked the student to move closer to the other side. And the other student was like, try really hard to hold the stick. Because if it's close to you, then you will need to use more force, right? Okay, so why? Why do you use more force? So we can use torque to solve this kind of question, okay? So first, I still say F1 add F2 need to equal to 300 Newton. And this doesn't change. This doesn't change, right? And then it's just how do we distribute this F1 and F2? Okay, so now let's say how do we use torque? So torque, first thing is we need to set the what? The pivot point, yeah, the pivot point. Because pivot point is the most important thing. So pivot point, and you can decide where you want to set the pivot point, right? So in this case, I'm going to set the pivot point over here. Okay, And the trick is, if you set the pivot point over here, then you can calculate this one. Okay? Or you can set the pivot point over here, then you will be able to calculate this one. Okay? So there are two pivot points over here. Okay? You can even set the pivot point at the middle, but that's become very hard to calculate. Okay? All right, let me say I'll set this point as pivot point. I'm going to call this point A, and then call this point B. Okay, so first I'm going to say set A as the pivot point. And then it becomes a question like you guys have done yesterday. So if A is the pivot point, now how many torque do I have over here? First, we have 3 force, right? 3 force could potentially have 3 torque. So let's have a look. First one, if this is a pivot point, does F1 has a torque? No, because F1 goes through the pivot point. If it goes through the pivot point, it's not going to make a turn because the distance is 0, right? Again, what is torque? Torque is the force times the perpendicular distance from the force to the pivot point. This one is already at the pivot point, so that one has a torque equal to 0. Right? Okay, and then let's look at this one. What kind of torque does this one have? Clockwise or anti-clockwise? Clockwise, yeah, that is the pivot point there, so this thing want to make it rotate around the pivot point like that one. Okay, all right, so gravity has a clockwise. So I'll label this. This is going to be clockwise. And what about F2? Anti-clockwise, right? Okay, so clock 2 is an anti-clockwise torque. Okay, so now what I can get is clockwise torque will need to equal to anti-clockwise torque. Does this make sense? Okay, and then I put the thing down. I'm gonna have my distance times my force. Clockwise, I know it's gravity, so it's gravity 300 times the distance. Distance is 1 meter over here. Right? And then my anti-clockwise is this F2 times the distance. And how much is the distance for F2? That is a 4 meter I have, right? From the pivot to the force. Okay, so 4 meter. So now F2 I rearrange equal to 300 divided by 4 becomes 75 Newton. Does this make sense? According to my rotational equilibrium, I can find out F2 is going to equal to 75 Newton. Yeah?
Why is F1 torque equal to 0?
That's because it's going through the pivot point. If you're going through the pivot point, your distance is 0. So the torque is 0. Yeah, it's just like this. If I'm pushing the door, right? I'm pushing at the hinges. Is it going to create any torque, make it rotate? No, only if I push over here, that's when I have a torque, right? So if you push on the hinges, then it doesn't work. Okay? All right, so now, this is one way of doing it over here. And obviously, not only I can set A as a pivot point, I can also set the B as a pivot point, right? So let me say this. If I set B as the pivot, let's see what's going to happen. If I set B as pivot, this is pivot, then which one is clockwise? So now I'll label here, this is the pivot now. Which one is clockwise? F1 is going to be clockwise, right? F2 doesn't have any torque anymore because it goes through the distance. What about this one? Anti-clockwise, okay. So now still clockwise equals to anti-clockwise. The clockwise is F1 and time the distance, I can call it D1. And then this one is going to be gravity, and then I'm going to times the distance of gravity. I'll say dg, the gravity force distance. Okay, F1 I don't know. Put F1 here. Okay, and then what is D1? D1 is a total from force to here. 4, yeah, that equals to gravity. Gravity is 300 Newton, and time the distance. What is the distance? 3 is from the gravity force to here. Okay, 3 meter. So now F1 equal to 900 divided by 4, which will give you 225 Newton. Does it make sense? Okay, and through this way, we've confirmed that yes, this force will need to be bigger. The F1 will equal to 225 Newton, and this one only needs 75 Newton. Okay, so, and you can use both of them, set two pivot points to solve this question, or you can just use one of them. And once you use one of them, you get F2, and you can put it back into your original equation over here. Because you know the two forces going up will equal to force going down. Then you can get the F1 must equal to 225 Newton. Does it make sense? Yeah, okay. So, which is F1 is going to equal to F gravity minus the F2. That will give you 225 Newton. Okay, does this make sense?
Yes.
Okay, see, so now I'm gonna give you guys a more difficult question to have a try, okay?